Okay. So number 2, which expression completes the fundamental trigonometric identity tan negative x? Y'all think it's B? How many of y'all think it's A? What about B? Okay, a handful of you are. What about C? And what about D? Okay? All right, the correct answer, according to our vote here, is B. And if you happen to have your trig identities written in front of you, which you won't, but if you did, then it's obvious that's an even-odd identity, isn't it? It says the tangent of negative x equals, well, the tangent of negative x is the negative of the tangent of x. It is. So B is the correct answer there. But what if you didn't have all those identities in front of you, and you won't, and you can't remember those identities, or you refuse to remember them, or whatever? Another option you could exercise would be something like this, and it's not the best way, but here's an option you could exercise. I always start with an angle that's familiar. I always use pi over 4, and the reason I do is I know that it is square root of 2 over 2, square root of 2 over 2. Remember the hand thing where you hold it up, the middle finger, right, is our pi over 4? Now, I'm doing this for a reason. If I wanted to find the tangent of pi over 4, it's my y divided by my x, isn't it? And the tangent of pi over 4 is 1, isn't it? Okay, now, why did I do all that? For this reason. I know that this says the tangent of negative x. So the tangent of negative pi over 4. Okay, now, pi over 4 is in the first quadrant. Negative pi over 4 is in the fourth quadrant. If y'all didn't know that, then you need to go back and think about how your angles are formed. But in the fourth quadrant, one of those things, one of the x's or the y's is negative. In this case, it's going to be the y, isn't it? So the point I'm making is that the tangent of negative 4 is actually equal to negative 1, isn't it? Right? Therefore, then, the tangent of negative pi over 4 is negative 1, which is the same thing as the negative of the tangent of pi over 4. The negative of the tangent of pi over 4 is also negative 1. That's sort of a way to confirm. Is it the best method? No, it's not the best method. Memorizing these is really the best method. And I'll go ahead and tell you on recording here that you could very well get an even-odd identity. Co-functions, I don't remember you having any there on the test. So the co-functions aren't going to be as important. But even-odd, you probably will have one on there. All right, question? Okay, you're talking about the way that you remember seeing them in the book. Okay, you're saying that the two in the middle are positive? Is that what you said? Mm-hmm. Okay, the way it's phrased in the book is that the middle is positive. I got it right here in front of me. The middles are positives and the two outsides are negative. That's not a bad way to do that. Okay? All right. Okay, so we have a question here that says factor the expression and use the fundamental identities to simplify. We have had a discussion here off of the recording, and most of y'all feel that it is answer choice B. Answer choice B is correct. Prove that. Use a little vote there. All right, B is correct. And this is why. First thing, it gives you a hint. It says factor. And so if I have the cosine squared of x times cosecant squared of x minus cosine squared of x, I have an expression here that has two terms. Here's the first term, here's the second term. You guys see that? Now, factoring, the first thing you always do with factoring is look, do you have something in common with all of your terms? And in this case, we do. We have a cosine squared of x in common with both of those. So that means that we can automatically pull that out, right? So the cosine squared of x comes out, and I have cosecant squared of x minus 1. And I know I'm right because cosine times cosine is cosine squared. Oh, sorry. Y'all should have caught me on this. cosecant, yeah, I need the square back, sorry. Cosine times cosecant is cosine cosecant. Cosine times -1 is cosine negative cosine. Still seeing that? So I factored it correctly. Now the question is does this match one of our answer choices up there? It doesn't, does it? So we got to go one step further. Let's focus on this part right here. Remember I told you that when you have a squared and a 1, with your trig stuff, go to your Pythagorean identities and see if you can do something with that. We have a Pythagorean identity that says this. It says 1 plus cotangent squared of x is equal to cosecant squared of x. We have that identity. Now here's what we want to know. Can we take this identity right here that I'm circling and somehow manipulate it so that we have cosecant squared of x minus 1? Yes, if we subtract 1 from both sides. So therefore, what it's saying is this. It's saying that this looks like this then. It's saying this. It's saying that the cotangent squared of x is equal to the cosecant squared of x minus 1. Now why is that useful? Because we want to see, do we have something in here that matches something up here? And the answer is yes, we do. So that means I can substitute this part right here with cotangent squared of x. I can substitute that now. So what that means then is that this thing right here becomes cosine squared of x times cotangent squared of x, which is answer choice B. Now this is good, and it does match, and in most cases when it matches, you're good with multiple choice, but it's not necessarily a bad idea, take this B out of the way, it's not necessarily a bad idea to at least explore, can this simplify any more? Like, what if we could do something and simplify it to just cosine, which is A, or just 1, which is C? Is that possible to do that? It's not a bad idea to explore that. And you can quickly do it by remembering this is a product right here. And so when you have a product, you want to turn it into reciprocals just to see if something cancels out. Like, for instance, I can tell already, I can say this, cosine squared of x, and cotangent is cosine squared of x over sine squared of x. So the question is if I multiply those together, would cosine eliminate? Or would something eliminate? The answer is no, it won't. I'll just end up with cosine to the 4th. So that confirms that B is my answer choice with that. Okay, this next problem, the recording button covers up a little bit of it, but the data here gives us the months of the year and the monthly cost of natural gas in an Oregon home. And down here in the instructions right here, it says which sine function best describes this data. There are a couple of ways to go about doing this. Really the best way, and I've told you this all along, is when you have data given to you, go ahead and put it in the calculator and work it that way. If we put it in our calculator, and I don't have the calculator screen up here, but when I do, when I go to the sine regression and I type in, or I go to my stat editor and I type in my list as August is 1, September is 2, October is 3, and then type in the corresponding cost numbers and do my sine regression, these are the numbers that I come up with for A, B, C, and D. Now I rounded, but that's what you're going to come up with essentially. So now what we need to do is just match. Our A is 47.956. And if you look down here, A, and this one is 48, that's 48, that's 48, and that's 48. So unfortunately, just due to the A part, we can't rule anything out. We can't, because 47.9 rounds to 48, and they all have that. So the next thing we want to look at is the D component. That's 69.039. Now if we look up here, we don't have that here, nor do we have that here. So just by the D part of things alone, we can rule out A and B as choices. We can rule those out. The next thing we will look at is the B. And if you notice, since we ruled out A and C, A and B, we don't want to worry about that. In this case, we have the same B in both of them. So just on b alone, we cannot rule out any equation. So that leaves us to look at our c coefficient. Which one of these c's is it going to match? Well, we know numerically that c is negative 2.089. We know that if we look at this one right here, answer choice C, our C coefficient is pi over 12. And if we look at answer choice D, our C coefficient is 2 pi over 3. So really we just put it in the calculator. And your calculator is not going to show on the screen here. If I literally just do pi divided by 12, I get 0.26 something. Right? And if I do 2 pi and I divide that by 3, I get 2.094. So just by looking at that alone, we can rule out C, and D becomes our answer choice there. All right, this question asks for the number of full cycles of the function that are found in this interval. All right, our function, and I'll rewrite it over here, our function is y is equal to 4 times the sine of x, and it's wanting it on the interval from negative 5 pi to 7 pi. First thing is, this word full cycles is just another way of saying periods. So it's wanting you to tell how many periods are in this function right here on the x-axis from negative 5 pi to 7 pi. So one way to conceptualize is just simply look at, all right, we have the graph of 4 times the sine of x. That's a sine graph. There is no shift vertically or horizontally. So it's going to look something like this, just in a rough sketch. So really what it's asking for is from, say, negative 5 pi on the x-axis all the way to 7 pi on the x-axis. This distance along here, it's wanting to know how many full waves are we going to have. Well, we got to figure out what's one period, what's one wave. So if you'll remember, the period is bound by 2 pi over b, and in this case, b is 1, right? Because b comes right here. There's nothing in there, so it's automatically a 1. So we know our period is 2 pi. So now here's the question. How many 2 pi's are there in this distance right here? Well, we got to figure out this distance. How do you figure out the distance? It's the larger number minus the smaller number. So 7 minus negative 5 pi is 12 pi. So what it's really asking is how many 2 pi's are there in 12 pi? 6. So the answer choice is A, which is 6. That is the correct answer choice, A. Okay. So this question right here, if you look at it, has already got some writing on it. And the correct answer is D as in dog, as the little ship there says. So we know that the correct answer is going to be 2 cosecant of x. Now this is a lot of work to go through, and off recording we talked about it, but in a nutshell, here's what happened. We have our 2 fractions. We have tangent of x over secant of x, secant of minus 1, secant minus 1 over tangent. And then this part right here is just that rational thing where we combine it, a over b, c over d. And the rest of the work and now revolves around the fact that what we want to do is see if we can simplify the top in such a way that something's going to cancel out with the bottom. So if you will look through here, you will see that in my lines I start to use dot, dot, dot in my denominator, which is just really me being lazy and not wanting to write the denominator out. All right, but if I multiply tangent times tangent, secant of x minus 1 and secant of x minus 1, I get tangent squared of x plus secant squared of x minus 2 secant of x plus 1. That's on my next line right here. And then I do some work. Now I see one little thing that I need to just clean up a little bit. This is going to be minus 2 secant of x. Okay? And the reason we simplified that is that the tangent squared of x, I have an identity written up here. I know that 1 plus tangent squared is equal to secant squared. And I notice down here, and you'll see them stricken out, that I have a tangent squared right here and a secant squared right here. And a 1. tangent squared plus 1 is secant squared. Right? And then from there, you just follow the pathway. Secant squared plus secant squared is 2 secant squared minus 2 secant of x. Now, I factored out a 2 secant of x. And then that allowed me to erase the secant of x minus 1. And so I'm left with 2 secant of x over tangent of x. And then your task there is to convert secant of x and tangent of x into something else. And in green below, I showed you that secant of x over tangent of x can turn into 1 over sine of x, which is the same thing as cosecant of x. So that's why the final answer is 2 times cosecant of x. Okay, a question like this. Identify the function that is graphed. All we want to do is identify what this thing looks like. Is it a negative tangent of 6x over 5? Is it cotangent of 5x over 6? Is it negative tangent of 5x over 6? Or is it negative cotangent of 6x over 5? There are probably different methods you could use by just simply looking at the graph itself. But quite honestly, the best way to do this is to put this into your calculator, into your y equals, and match the graph. Now, as I'm talking, you will not see this on the screen, but just a couple of things to notice. First thing, if I think that answer choice A is correct, then what I want to do is type into my y equals negative tangent of 6x over 5. That's going to be pretty easy to type in. I'm just going to we'll go to my y equals, we'll type in the negative, and then tangent, and then just simply do 6x divided by 5. Make sure I close it like that. And then what I don't want to do is just simply hit graph, because if I hit graph, I'm not saying that you won't get something you can work with, but you may not get a window that matches the window displayed right here. And so the quickest way to get that window where you have a minimum of negative 2 pi, and a maximum x of 2 pi, and a maximum y of 5, and a minimum y of negative 5, is just to simply hit zoom and then 7. Zoom and then 7. And that will put it into what we call the zoom trig window, or the Z trig. And that at least gives you something to work with. So any of these problems where we're just asked to graph, any of these, then you should put them in the zoom trig window, because they're all pretty much going to be identical. Now, the next thing you look for then is the graph that's on your calculator screen. Look at the origin. In this case, yours should go through the origin. And then also look everything to the right of the origin. In this case, you have one complete, I call it an S, and then a partial S on there. Okay? So that's sort of the long and short of that. If you go through all these, you will find that the best answer choice is going to be C. The best answer choice will be C. That will match the graph that we have on here. All right, this question asks us to identify the graph that has a phase shift. That's a horizontal shift of negative pi over 3, and a vertical shift of negative 2. And we're also told that these are cosine functions. Okay, and now that's going to be important, because remember, without any shifts or anything, cosine always starts at a maximum and then goes like that. It always does, with no shifts or anything. Okay? Now, if it shifts, then it's either going to go right or the left. But the point is that our focus is going to be on this maximum point and where it is in a shift. That's going to be our focus on this thing here. Now, first thing, let's do the obvious. It has a vertical shift of negative 2, doesn't it? Which should mean, and I hope this thing will work. Let's do it this way. We'll take this out for a second. All right, and then I'm going to do up here. And the reason I'm doing that is because we know cosine starts like this, but if it has a vertical shift of negative 2, it slides downward, doesn't it? So if we look at this, can we automatically rule out answer choice C? We can automatically rule that out, can't we? Right? Well, why can you rule out D? Someone said rule out D. D looks like it shifted downward. In fact, all of these look like they shifted downward. Well, I hear someone say it shifted to the right, and others say it didn't shift to the left. That's because you had the answer choice in front of you. But when I was off recording, I asked a lot of y'all, some of y'all chose D. All right? Now, here's why B is the correct answer. We have this thing called the phase shift, which is negative pi over 3. That means our C coefficient, this right here, means that C in our equation is equal to negative pi over 3. That's what that means. It says C is negative pi over 3. Now, if you will remember, the phase shift is dictated by this bx minus c kind of thing, right? Right? So if I do this, whatever b is, x minus c, I have negative pi over 3, which really translates to bx plus pi over 3. Now, if you'll remember, plus pi over 3 means the whole thing is shifted to the left, doesn't it? Remember that? Right now, if you don't catch that, this phase shift says it's negative pi. That means the whole graph shifts to the left by pi over 3. So we know it's shifted down by 2, but remember our focus is on the maximum point right here. So it's got to shift over to there, right there. So I know then that our point should be to the left by pi over 3. Now if I look at that, we know we're looking at A, B, or D is the correct answer. If you look at D, this maximum point right here did not shift to the left. It shifted to the right. We look right here, this maximum point also shifted to the right. It did not shift to the left. The only one that shifted to the left was this right here. And that's why B is the correct answer. Okay, this question here, we can tell by our answer on the top right, the little boat has C. C is the correct answer. This one here is going to be just a matching. I'll try to pull it down a little bit. It says identify the graph of the function given below. Here's the function right here. And again, you know, we could analyze this and say, well, we know the amplitude is 1.5 and B is 4 over 3. So our period is going to be, and we could try to go through all that. But since we have the function and we have graphing calculators, it's easiest just to type this in the graphing calculator. Now, if you remember from the other slides, typing it in correctly is important, and setting your window up is important. If you type this in, remember that it's going to have to look like this. Y is equal to 1.5, right? And then you're going to do the cosecant, which is 1 divided by the sine. Actually, let me write this a little clearer over here. Okay? Y is equal to 1.5 times 1 divided by the sine of 4x over 3. And you have 2 parentheses. So make sure you type that in correctly. And then the next thing is make sure that you're in the correct window. Remember, that's the zoom 7. And then you also need to make sure you're in radian mode. Once you do that, then you just simply match, and you will see that C is the only one that perfectly matches. And again, what we look for is we look at what happens at the origin, and then we look at everything to the right. That's what we focus on for the match there. So C is the correct answer choice there. All right, here's our last one here. Identify the function shown in the graph. We know the answer choice is A. Here's how we know that. First thing, you can tell by looking at this that this thing goes up to here and down to here, and that these are equidistant. They're the same, which tells you that the x-axis is the median line or the midline. We can also tell then that the period of this function starts at the midline, right, and then goes like this. And the reason I'm doing this is because any function, not that goes through the origin, but that starts its period at the origin, and the midline is the x-axis, is a sine function. So we're automatically dealing with answer choice A or C. So B is not going to work, neither is D. But the next thing we notice, what's the difference between A and C? Well, A has a coefficient 4.5 in front of the graph, and C has a coefficient of 4.5 in front of the x. One of these refers to the amplitude, one of these refers to the B coefficient. And if we look at this, the amplitude, we know from 0, we go up 1, 2, 3, 4, and it looks like 4.5. And then down, 1, 2, 3, 4, looks like 4.5. So therefore, our amplitude is 4.5, which makes our A coefficient 4.5, which makes this answer choice the correct one.